Hi guys, welcome to VT engineering class. In today's class, we'll be looking at one of the major courses in engineering, which is engineering mechanics. So this course is a first year course when you are in the 211 first semester. So now, we'll be looking at how to calculate the reaction at the end of a what beam. Please, before you watch, I want you to watch our previous video on beam, type of support, and type of what load. Is well explained. So now from this is nothing but a simply supported beam. We've already explained this. So now a simple supported beam is having a hinge support and a rolling support, and the length of the beam is what L. This is the weight acting on the beam. So now the next thing you need to do is you need to draw the free body diagram. This is the free body diagram. Look at this. You can see this is 2, this is 1. Why? Now it is because we are having a hinge support. I've explained from our previous video that a hinge support is having two reactions. We have the horizontal reaction and the vertical. So now, and our rolling support is having a horizontal reaction. You get that? So now, you may want to ask for the reason. Just watch the previous video. Everything has been explained. So now, here, this is our vertical reaction. This is also a vertical reaction. This is a horizontal reaction. So we have a horizontal reaction at point A. We have a vertical reaction at point B. Point A. And we have a vertical reaction at point B. Don't forget that this is our free body diagram. You get that? So now if you look at this weight, it's acting at the center of the beam. You get that? That is why the length is divided into half. L over 2, L over 2. From this point to this point is L over 2. From this point to this point is L over 2. L over 2 plus L over 2 will give us L. Because this weight is acting at the center of the beam. You get that? So now the next thing is, if this weight is acting at the center of this beam, these two reactions that you are seeing, they are there for you. They are there showing that they are going to counterbalance the reaction of this weight. That is why we say sum of this upward force must be equal to sum of this downward force. If they are not equal, this beam will not be able to stable. It will not be in equilibrium. You get that? So now the next step is sum of upward force equals to sum of downward force. So sum of sum of upward force equals to sum of downward force. I've explained that. Okay, so now what are the upward forces that we are having here? We are having RA and RB. So it means sum of RA plus RB will be equals to downward force, and we are having only one downward force here, which is W. You can call this your equation 1. Do you get that? I'll still come back to this. Okay, this one is an horizontal reaction. Do you get that? So now the next thing is to take our moment. We can take our moment at any point that we like. Do you get that? We can take it at this point A. We can take it at point B. Do you get that? So now let's take our moment at point A. So if we take our moment at any point, don't forget that the moment at that point will be equal to 0. If you take your moment at point A, the moment at A here is nothing but 0. So it means if I take my moment here, we'll be having how many force now? 1 and 2. We'll be having this force and this force. So we'll take, and when we say what is moment now? Moment is force times perpendicular distance. So and this one is a force. Weight is a force. RB, a reaction, is also a force. So you see that this weight here, W, we cover the distance from here to here. What is the distance? L over 2. And if you see, it is perpendicular. What is the meaning of perpendicular? It means they are at angle? 90 degrees. Look at this. You get that? So this is perpendicular, and it's covering. It will now be force times perpendicular distance. Look at this force. times the whole, it will cover the whole length. Do you get that? So now we take a moment. Taking a moment at point A equals to what? 0. Do you get that? So now let's take the moment now. Now I'm going to put my hand there, then we take the moment together. Let's start with arrow B. This is force, arrow B, right? So now arrow B is a force. Force times perpendicular distance. So it means arrow B times what? The total distance, because it will cover this distance. Look at this, it will come like this. Do you get that? And this one too will come like this. Do you get that? So now, okay, so now this one is coming like this, while this one too is coming like this, right? So we are now going to have arrow B times what? Times the total distance, which is what? Which is L. Now look at this. When this one is acting like this, when it's coming like this, it is nothing but what? It's moving upward. Do you get that? And this one is a downward force. Do you get that? It's coming like this. So this upward force, we can say let our upward force be positive and our downward force be what? Negative. Do you get that? So now here, if I take my upward force as positive, it means it will just be what? Arrow B times what? L. Do you get that? So now if I take my downward force as negative, look at this, it is downward. So W will be what? Minus W times the total distance, which is what? L over 2. So it's going to be minus W times L over 2. Do we have any other force here again? No. Everything will be equal to what? 0. Do you get that? So now for me to get my arrow B now, I can say arrow B L equals to, this one is negative, if you cross to the other side, it will be what? Positive. L over what? Over 2. Do you get that? So now for me to get my arrow B now, I will divide both sides by what? L. So arrow B will be equal to what? WL all over 2 divided by what? L. You get that? So now arrow B will be equals to WL over 2 divided by L over 1. So arrow B is equals to WL over 2 times 1 over what? L. So this L will cancel out this L. Arrow B is equals to what? W over 2. Do you get that? So now, can we get our arrow A? Yes, we can get it. But you know, for the case of exam, you don't need to be wasting your time solving this step. As an engineering student, your head must be calculated. Look at this, arrow B head equals to WL over 2. From here, L will cancel out L, then we have what? W over 2. But for the sake of those ones just coming, that's why I did this. You get that? So now our arrow B is what? W over what? 2. Can I get my arrow A? Yes, I can get my arrow A. Now from this equation number 1, from equation 1, what is in equation 1? Arrow A plus what? Arrow B equals to what? Equals to W. That is what is there. So now I'm going to substitute W over 2 for arrow B in this equation. So now this one will be arrow A plus W over 2, because arrow B is here. So W over 2 equals to what? W. So for me to get my arrow A now, arrow A will be equals to W. This one will come to this as minus W over 2. Do you get that? And you can find the LCM now, 1 and 2. So arrow A will be equals to, you find the LCM of 1 and 2 is nothing but what? 2. And 1 in 2 is what? 2. 2 times W is still what? 2 times W is what? 2W. We have 2W minus 2 in 2 is what? 1. 1 times W is what? W. So arrow A is equal to what? 2W minus what? W is what? W over what? 2. So you can see that our arrow B is equal to what? W over 2, and our arrow A is equal to what? W over 2. So now, if you want to test, maybe your answer is correct. Look at this. We said sum of upward force equals to what? Sum of downward force. Let's try. Let's look at it. Maybe it is correct. Yes. What are the sum of what is our arrow A? Let's sum arrow A plus arrow B. Maybe we are going to get W. Look at this. Our ROA is what? W over 2 plus W. Our ROB is also what? W over 2. Now look at this. Find the LCM of 2 and 2 is what? 2. 1 in 2 is what? 1. 1 times W is what? W plus 2 in 2 is what? 1. 1 times W is also what? W. W plus W is what? 2W. 2W over 2. You see these two, cancel out these two, then we get what? W. So it shows that mathematics is true. So sum of upward forces is equals to what? Sum of downward force. I hope you understand this. And if you are still, you can still decide. Maybe we can take the moment from this side. You can do that. And when you do that, I would like to see your working. You can take a screenshot of that and send it in the comment section. Thank you. Remain your beloved tutor, Jero.